Hey guys, today I'm going to be looking at CNCM Online Round 1 Problem 3. I'm Eli Park and this problem was written by Albert Wang. So first let's read the problem. Define S of n to be the sum of the digits of n when it is written in base 10 and take S of k of n is equal to S of etc. of n etc. with k applications of S. The stability of a number n is defined to be the smallest positive integer k, where S of k of n is equal to S of k plus 1 of n is equal to S of k plus 2 of n, etc., to infinity. Let T of 3 be the set of all natural numbers with stability 3. Compute the sum of the two least entries of T3. So first, let's try to understand what's going on here. What exactly is our function s doing? Well, we know it's going to be the sum of the digits of n, which is a pretty straightforward function, but we want to see how that applies to our somewhat interesting looking condition right here. This one will include infinity. So first, like we want to do whenever we want to understand how something works well, we take small cases. So, well, let's take the smallest natural number, 1. We see if we apply S of n, so from here on I'm going to denote arrows as an application of S. So 1 is going to map to 1, and that should be pretty clear, because the sum of the digits of 1 is just 1. This maps to 1, and this just goes on forever. Well, that wasn't that interesting, but let's still look at what the stability of this number is. For our notation here, we know that this is S of n, or equivalently S of 1 of n, making this S of 0 of n. And since by our notation here, it already starts, just everything is all equal, we see that this is our stability right there. So our stability of 1 is going to be equal to 0. And we can see here that the same thing occurs for any one-digit number. 2 just keeps mapping to itself, blah, 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 and all one-digit numbers just keep mapping to itself. So all one-digit numbers have stability 0. And this should make sense without actually having to go through each one, because the sum of the digits of a single digit number is itself. So we see that the single digits numbers are all in T1. And then just with a little bit more thought, you can realize that the single digits numbers are T1. So there are no other numbers in T1 because any non-single digit number has to have 2 or more digits, and the sum of those digits can never equal itself. So we see that T1 is just going to be the one-digit numbers. So that's pretty good progress so far. So let's start thinking about the numbers with stability 1. What kind of numbers have stability 1? Well, by our definition of S, we see that those numbers are the ones that have sum of digits that is a single digit number. So for example, we can take, we'll take 34. The sum of the digits is 3 plus 4 is equal to 7, and 7 is a one-digit number. So that is an example of a number with stability 1. But we want to, because although 34 is one of those numbers, we're not particularly interested in 34 or a random number. We're interested in the least entries of T3. That's our final thing. So although that doesn't necessarily imply that we only care about the least entries of T1, but it's still worth noting that we do kind of want to have our general focus on the smaller side. So just by a little thinking, we see that 10 is the smallest number of stability 2 because the sum of the digits is 1, and this just keeps going on forever. So this has stability 1. And similar, 11 also has stability 1, like that. And we could look at some larger numbers, but we're just gonna note, I'll just put, oh wait, shoot, these should be 2s here, sorry, my bad. 2, 2, and 2, and I'll just put 12 because why not? So we're not going to be particularly interested in anything larger than that because we see that it might just get too big. It's going to have to get too big, and we'll see why here. So So we see that 10, 11, and 12 are part of the set T1. So now we're interested in T2. T2. We want those are the numbers that have some of the digits in T1. So for example, a number with some of the digits in T1, for example, could be 39, because 3 plus 9 is equal to 12, and 12 is in the set T1. But again, we're not particularly interested in those larger numbers. We're interested in the smallest ones. Well, the smallest one, if you think about it, is going to be 19, because we take our smallest number in T1 and take the smallest number that has sum of digits 10. And some other examples could be 28, something that sums to 11 would be 29, 37, 38, 39 sums to 12, like I said earlier. So these are solid examples, and these values are all part of the set T2. But so now we're looking at this, and we can basically tell that, without not completely rigorous, but it is very clear to us that anything, if the larger the sum of the digits, the larger the number has to get. Meaning, like, we see here the smallest number in T2, the sum of the digits of the smallest number in T2 has to be the smallest number in T1. So the smallest number here has, the sum of the digits is the smallest number in T1. And this should make sense. And so should the second smallest. And we see that. So using that general idea, we're just gonna erase this up here and start moving on to T3. So we'll just list the three smallest numbers. Anything greater than that is kind of irrelevant to us now, because the numbers get too big. Let me erase that. So now we want the smallest numbers in T3. Well, the smallest number that has sum of digits 19 is going to be 199. And this is going to have to be our smallest number in T3. But we're not done yet. We want sum of the two least entries of T3. So let's just take the next smallest number that has sum of digits 19, which would be 289. That's going to be our candidate for our second least entry. Let's see the smallest number with sum of digits 28. It's going to be 1999. This is significantly bigger than 289, and we see here that the smallest number here is going to be 2999, and it only has to get bigger. So we see here that we're done now, because these two are going to be our smallest two entries in T3. So we just need to sum 199 and 289, which will yield 488. That will be our answer.